Hey everybody, welcome to another Tech Talk, another DigitalOcean Tech Talk. My name is Otto. I am a first-time host of DigitalOcean Tech Talks, and today we will be talking about running your MongoDB database on DigitalOcean. But before we kick off, I want to welcome everybody. Happy May the 4th. Today we're going to be building a fun little app based around a Star Wars theme. We're going to learn about MongoDB. We're going to learn about DigitalOcean, and we're going to have a whole lot of fun doing it. So welcome, everybody. Where's everybody tuning in from today? And also, what is your favorite Star Wars movie? For me, it would have to be the original trilogy. I just really couldn't get into the newer movies too much, but original trilogy for me. So I'll share my screen and we can slowly get started. See, we have a couple of people from Las Vegas, and that's where I'm from. That's where I'm tuning in from. And we have Peter from Germany. Hey, Peter. Poland, awesome. Well, welcome everybody. I hope you learned something today, and I want to make this stream really, really interactive. So please feel free to ask any questions. Stop me as I'm making progress, and we'll be happy to kind of make adjustments on the fly. But let's kick it off. Welcome, Florina from Romania. Sweet. So let's talk about MongoDB. If you're not familiar with MongoDB, MongoDB is a document database. It is a NoSQL database that allows you to essentially structure your data however you want. And this kind of gives you a whole set of flexibility to quickly iterate in building applications. You can change your data model on the fly. You can just send any essentially valid JSON data into the database, query it, access it, modify it however you want. And there is so much to talk about when it comes to MongoDB. And in this tech talk, we're aiming it at beginners. So we're going to show you how to set up a MongoDB cluster on DigitalOcean, how to connect to it via MongoDB Compass, which is a really cool GUI tool that will allow you to kind of visualize your data and kind of get a soft landing in exploring and learning about MongoDB. And then we're going to go ahead and build an actual application with MongoDB and Node.js. Hey, Oliver from Belgium. And we have somebody from Hong Kong as well. So we have a pretty global audience today. So welcome, everybody. Once again, happy May the 4th. And let's kick it off. So the first thing we're going to need to do is create our MongoDB fully managed cluster on DigitalOcean. And to do that, we are going to log into our DigitalOcean dashboard and head over to the databases section. And let me zoom in a little bit so it's easier to see what I'm doing here. And if you have any questions, feel free to post them in the chat. I will be glancing over at my chat screen on my second monitor. So if I'm looking over, that's what I'm doing. Hey, Kim. Hey, Ivan. So let's create our first MongoDB database. So I'm going to navigate to the databases section, click the Create button at the top right, and hit Database. And then from here, we have a number of different options. We could create a managed MongoDB database, a Postgres, MySQL, or Redis database. This talk, we're focusing on MongoDB. And the next thing we need to do is decide what type of infrastructure we want to deploy our database on. And there's actually three types. So there's a basic nodes, general purpose, and storage optimized nodes, which are dedicated droplets for your MongoDB database. So if you have a specific use case where you need a lot more CPU because you have a large amount of writes that you're doing to the database, or you just need a lot more power from your infrastructure, you could select a general purpose node, which starts off with 4 gigabytes of dedicated memory and per dedicated CPU. And the general purpose and the storage optimized nodes are a little bit more expensive. But for our use case, we could just start with a basic node as we kind of prototype and build our application. The basic nodes start at $15 a month, and you get 1 gig of RAM, one virtual CPU, and 15 gigabytes of disk space, which will be more than enough hardware for our sample application. And what we're going to do is deploy just a single node MongoDB database. We could add a 3-node replica set by adding 2 standby nodes, which will give us that high availability in case one of the nodes goes down. We can fall back to a different node, or if our nodes are globally distributed, we can have much faster read access from the separate nodes. But for our app today, we could just start very simply with a single node using a shared CPU. And the next and final thing we need to do is just choose a data center where we're going to deploy this application to. And so we can do it in New York and San Francisco in the United States. We could deploy it in Europe, in APAC. And for me, let's just keep the defaults and deploy our MongoDB database in New York in data center number 3. Everything else we can leave as is. Choosing a unique database cluster name, let's just say May the 4th. And with that, we're ready to create our database. Now, this is going to take a couple of minutes to provision, deploy, and get our database ready. So while we are waiting for that to complete, let's take a look in the questions and see if anybody has any questions so far. And it looks like we got one from Bleeb84. Are managed databases also upgraded to newer versions automatically? So they are. So minor versions of the database we can automatically migrate, but when it comes to major versions, like currently we're on MongoDB 4.4. So, when MongoDB 5.0 or 6.0 or, whichever major version becomes available, you would have to migrate that yourself. But for minor patches, we could do that automatically for you as part of the managed service. So our database is still being created and deployed, and this usually takes about 5 minutes. It might be a little less. But while we wait for this to complete, we can take a look at how we're going to actually connect to our MongoDB database. So we can see our connection details here on the right. And by default, we're going to create a DigitalOcean is going to create a user for you with the name of DOAdmin and show you a password for one time where you're supposed to copy it. Otherwise, you're going to have to create a new user account. It's going to give us our host name, the port that the database is going to be deployed to, and then which database to connect to by default. And one really cool feature that we are working on to make connecting to MongoDB on DigitalOcean even better is a feature called Trusted Certificates. So at the moment, if you go and deploy a database, you're going to have to download the CA certificate. And when you connect to your MongoDB database, whether it's with Compass or through your application, you're going to have to use the downloaded certificate. But I was lucky enough to get early access to our Trusted Cert feature, where we no longer have to download the CA certificate. We can just provide the connection string with our username and password, and we'll be able to securely connect to MongoDB. And I'm going to show you how that works. So our database is still being built, but we can get our connection string ready, and so that as soon as it is deployed, we can connect to our database. So I will get the connection string here from the dropdown, And this is what the typical MongoDB connection string looks like. We have the protocol, our username and password, which cluster we're connecting to, and then at the moment, we're still seeing this TLS CA file, but we don't need to use that one, or we won't be when the trusted certs are out for everybody. So I'm going to click the Show Password button, which is going to show me my temporary password. I'm going to copy everything up to the TLSCA file and copy it. And remember, the password is only temporarily available. So once I leave the screen, it's no longer going to be visible. And you might think, hey, why are you showing your password here? With trusted sources, I'm going to be able to restrict access to the application, to my MongoDB cluster based on IP or based on certain DigitalOcean apps that I deploy. So, even if you have the password, it doesn't mean you're going to be able to connect to my database and steal my data. So our database is still being deployed, but let's go into Compass and paste our connection string. And if we try to connect right now, it should fail. It looks like our database is already up and running. And wow, we timed that exactly right. So as soon as I hit the connect, the database deployed, and we are good to go. So by default, we're going to have an admin database config and local. But for our application, we're going to want to create a new database to work with. And to do that in MongoDB Compass, we can just hit the little plus sign here at the bottom left and click the Create Database button. And to create a database, we need to give it a name and a starting collection. Now, before we do that, let's take a look at the data that we're going to work with. So I found this open source library called Star Wars API, which has a list of Star Wars characters in JSON format. So it doesn't have the entire Star Wars universe, but it does have a list of about 88 different characters, and it has a lot of different information on the individual characters. So we have their name, Luke Skywalker, homeworld, where they were born, where they died. Sorry if there's any spoilers here, and so on and so forth. So this is what our data model is going to look like, and I'll show you how we can import this data model into our database. But first, let's go ahead and create the database. We'll call it Star Wars, and our collection name is going to be characters. So the actors or the characters in the Star Wars universe. And then from here, we're going to click the Create Database button, which is going to automatically create that for us. So we have our Star Wars database, and then we have this characters collection. And collections in MongoDB, you can think of them as, if you're coming from the SQL world, collections can be mapped to tables. So, it goes database, collection, and then individual documents, which in the SQL world would be similar to rows. But in the document data model, they are much more flexible than just columns and individual values. Now, there is a question in the comments I'm going to get to, and then we'll continue on forward. So Fintech asks, does the CA certificate expire? If you are using the trusted certs, it will automatically kind of renew itself when it has expired. And Swalan is also joining us from St. Lucia. So welcome, Swalan, as well. So to add data to our MongoDB collection, there's a couple of different ways we can do it. We can hit the Add Data button and insert a document. And this is going to give us an interface to go ahead and add our data. So I could start by looking over at my browser window and adding data like this. So Luke Skywalker, and inserting it. But this would take a really, really long time, right? I mean, I'm sure you didn't join this tech talk to see me type for 3 hours to get 20 characters in. So while we can do it this way, with MongoDB Compass, we can actually import JSON data with the click of a button. So let's actually delete this record here. And let's go back into our browser here and just save this JSON document to our computer. So I'm just going to right click, hit save as, and we'll create a new repo here called May the 4th. Go into it, and I'll save our data as data.json, and we'll just make it a JSON file. And then from here, we'll go into that May the 4th library, and let's open up Visual Studio Code. I'm just going to make one quick change here, and actually, let me show you what will happen. So if I go into Add Data, import a file, select our file from May the 4th, add our data, make sure to select JSON because we're importing JSON data, not CSV data, hit import. This is going to work just fine, but we will see a little issue where we have our ID field from that API, which has the character names, but we also have this underscore ID, which has a data type of object ID and then a list of numbers. And this underscore ID does not exist in our JSON data. And this is because this is a required field in MongoDB. Every document has to have an underscore ID field, which is the unique identifier for MongoDB. And it doesn't have to be an object ID. It can be a regular number. It could be a string. It could be any sort of any sort of data type, but we have to have the underscore ID field. So rather than have an underscore ID and an ID, what we can do is go into our JSON data, and we can replace all of the ID fields with underscore ID. And that's going to ensure that when we import this data, we don't have two instances of a very similar data type. So let's go back in here. I will drop this collection. So I'm going to delete all the data in the collection, collect characters. And if you don't have a collection in your MongoDB database, it's also going to automatically delete the database. So we're going to have to recreate it. Star Wars characters. And if you have any additional questions, if I'm moving too fast, please feel free to let me know in the chat and comments, and I will make adjustments on the fly. So we'll recreate this database, import our data as we did before. Make sure we saved it, JSON, and import. So now we're good. So now we still have that underscore ID field, but now instead of it being an object ID, it is an integer. So 1, 2, 3, et cetera, et cetera. Cool. So before we get into building an API with this data, I do want to very quickly walk you through MongoDB Compass and show you how you can work with your MongoDB data. And also let me zoom in a little bit so it's easier to see. Cool. So MongoDB Compass is, like I mentioned earlier, it is a GUI tool that allows you to visualize and work with your MongoDB data without having to connect, without having to write any additional code. You just download it. It's available on, Windows, Mac, Linux. If you just install it, give it your connection string, and you will see all of your data and be able to make changes to it, visualize it, and do all sorts of cool stuff. So one of the first things we can do is view our data, right? So we can see that we have various data types here. We have strings like the character's name, their height, which is a floating point. But then with MongoDB, one of the cool things that you can do is you can have embedded documents, which could be arrays, like in this case. You can see that the masters and apprentices, and these are array object types. But we can also add additional data to this document. So we'll hit Edit Document, and at the bottom here, we can add an additional item. Let's just say add a field, and let's say we want this field to be something other than a string, so we could turn it into any of these data types. So we could turn it into an object. And now, as part of this object, we can add additional fields, something cool, for example, awesome. And then we can add additional fields to our object. So with MongoDB, you can add any sort of, as long as it's valid JSON, you can add it into your data model, into your MongoDB document. So I'm going to delete this one for now, since we won't be making that change. But you can visualize your data this way, but you can also click on the schema button and further analyze the types of documents that you have in your MongoDB collection. So for example, if we take a look at when the characters were born, it gives us a nice table, like, which planet were they born on, so the born location. 33% of the characters in this particular data set were born on Naboo, their class, their cybernetics, where they were destroyed, for example, and all sorts of various data. So depending on the data type in your collection, if you look at the schema, it's going to automatically give you kind of interesting information about the characters. So that's examining the schema. If we look at our documents, we can also filter our documents. So if we wanted to show only characters that are male, for example, we could just write a filter for gender and say male, for example. And now we have a total data set of 87 characters. But if we only want the male characters, we write a query saying that we want the gender to be male. Run find, and it's M. Now we have 68 characters, and they're all going to have the gender male property. But we can also say, characters that are greater than a particular weight. So let's say that have a mass greater than 50. Oops. So we had a little issue here. Let's see. Fresh. Oh, well, we'll revisit that in our application. The next thing I wanted to show you, and let's reset the filters here, is the explain plan. Now, this is very, very powerful as you start building your applications. You're going to want your data to be returned to you as quickly as possible. So when you do write a query to get a specific set of data, you're going to, and if you're having performance issues, if it takes a while to load the data, the explain plan is going to tell you how the query executes on the MongoDB server. So here, if we do just the general, get us all of the documents in our collection, we're going to be doing a call scan or a collection scan, meaning that without any filters added to our application, we're going to have to go and scan the entire database. And in our case here, we have 87 documents, so it's not too terrible. We can very quickly, in 0 milliseconds, get all of our documents and show them, load them in our application. But if you had, 2 million, 5 million, 100 million records, doing a collection scan is going to be very, very slow because you're going to have to scan all of those documents. So this is where indexes come in. And hey, Christopher, welcome from Georgia. This is where indexes come in. And the indexes tab tells you which indexes you have created on your MongoDB database. And by default, every single time you create a new collection, it's automatically going to create an index on the underscore ID field. So if we were to run a query where we say, get us the ID one. So we're going to say, get us the particular document with an underscore ID of 1, and write that explain. It's going to allow us to very quickly, do an ID hack. So we're using an index here, and it tells us, query use the following index underscore ID, and we're able to get this document again. Since we only have 87 documents, it's still going to be very, very quick. But now, instead of looking through that entire collection, we were able to use an index to very quickly identify where in memory, where in our database this document is, and retrieve it very quickly. But since we only have an index on the underscore ID field, if we were to search for, say, let's take a look at our documents here, and let's say we wanted all of the characters with the eye color of blue. So we'll say eye color field is blue. If we were to run an explain on this, again, it's going to do a collection scan. So it's going to have to look at all 87 documents just to return the 15 or so that have the character with the eye color of blue. And we can also see that no index was available for this query. So if we had a lot more documents in here, and if our data was all over the place, then this query might take longer to execute. So let's go ahead and create an index really quickly on the eye color field so that we can actually use an index when we start building our application. So we'll go into indexes here, create an index. We'll say eye color for the name. And then for our type here, we're going to say eye color. And we're just going to do it in ascending, or you could do it in ascending order, descending, a 2D sphere if you're working with geolocation data, as well as a text field if you're trying to add search capabilities. But ascending works for us here. And we're just making a simple index on one field. And we can make it much more complex with compound indexes, but that's a little bit out of the scope of this tutorial here today. So we'll hit create index, and this is only going to take a couple seconds to create since we don't have a lot of data. But now if we go back to our explain plan, execute this same filter, run explain, we were able to use an IX scan, so an index scan using our eye color index, and fetch only the 15 records that have the eye color of blue. So rather than looking at our entire data set of potentially hundreds of thousands or millions of records, we were able to examine only the 15 that had that were in the index and get those. So that's a little bit about indexes. And the other two features of MongoDB Compass that really allow a beginner and to start learning about MongoDB are the validations. So by default, I mentioned earlier in this talk that you can add any sort of data you want in your MongoDB database. So whether you're any valid data can be put in any collection, but validation rules allow you to kind of enforce a data schema like you might in a traditional relational database like MySQL or Postgres, where you can say, this field has to be a string, this field has to be an integer, this field is required, this field is not required, this field can have a minimum or maximum value of so-and-so. And so that's validation rules. So they're a little bit out of the scope of this tutorial, as well as the MongoDB aggregation pipeline. So the MongoDB aggregation pipeline is another really, really powerful feature that's a little bit out of scope for today, but really allows you to turn your data into pipelines. And as you're writing queries, you can transform the data to suit any particular use case. So you can, group particular data, you can run additional operations, you can add, remove specific fields, and just very, very quickly transform your data on the MongoDB server before it gets sent to your application. And like I said, it's a little bit out of the scope for this tutorial, but if you'd like to learn more about the aggregation pipeline, we can do another tech talk. And I do want to do a quick pitch for future tech talks. What would you like to learn more about when it comes to MongoDB or any other technologies? Let us know in the comments, and we'll get to actually building our application. So we have our database, we have our collection, which has our characters in it. So we have about 87 different Star Wars characters. And the application that I want to build is going to allow us as the end user to vote, to basically, pit two characters against each other and have them battle it out. And we're going to do this by building a simple Node.js application. So to do that, I'm going to open up Visual Studio Code. And so we have our data.json here. Let's close it for a second and open that entire folder. So GitHub May 4th. We are good here. So at the moment, we only have this data.json file. But let's go ahead and create a package.json, since we'll be building a Node.js application. Let's go ahead and create an index.js for our server. And let's go ahead and add our dependencies next. So let me log in here as well, or zoom in a little bit just so it's easier to see. And the first thing we're going to do is install our dependencies. So we're going to bring in npm install express. We're going to be making a simple express application. MongoDB, since we'll be working with MongoDB, .env, so that we can load our MongoDB connection string from our environment rather than hard coding it. And we're also going to bring an EJS library, which is going to allow us to render some HTML and embed dynamic data into it. So these are the 4 dependencies we're going to have. We're going to save them as dependencies. And this is going to, had the save in the wrong place. Let's delete this package.json. I think it's failing because I didn't properly format it. That's all good. So we'll just skip it, and then we'll create that file later. So this is going to take about a couple of seconds to install our Node modules. We can see all of them here. And now we're ready to start building our application. The first thing we're going to want to do is set up our environment variable. So we'll hit create a new file, call it .env. And what we're going to store in here is our MongoDB connection string, that MongoDB URI, MongoDB_URI. And to get that URI, we can go back into our database here. And again, I'm just going to copy and paste it. TLS true. And again, remember, since I have access to the trusted search feature, which should be rolling out to everybody in a little bit, I don't have to use the CA certificate. But if you're following along, you're going to have to download the CA cert and replace it with your path. The other thing I want to do here really quickly is secure this database cluster by restricting access to just my IP. So if you copied my database password earlier, technically you could connect right now, but as soon as I add this trusted certificate, my current computer IP address, it's going to block all incoming connections outside of my particular IP here. So with that said, let's go back into Visual Studio Code, and we're going to paste our MongoDB URI, which has our username, password, which database we want to connect to, and so on and so forth. We'll save that. And next, let's go ahead and write our server. So to get started, the first thing we're going to do is require that .env package and tell it to load our environment variables when the application starts up. So this first line is going to do just that. It's going to load in the MongoDB URI and then any of the other environment variables from our operating system. Next, we're going to require Express, and I have GitHub Copilot running as well. If it gets annoying, I'm going to turn it off, but for now, it'll help us set up our application. So we're going to set up our app, and let's also bring in our MongoDB client. So we can say const mongo client, fire it from the MongoDB package. So we are good to go so far. The final thing we're going to do is just have our application listen on port 8080. 8080. Actually, I'm going to turn off Copilot for now, just so that it doesn't, show you a whole bunch of code that you might not care about. So we're looking pretty good so far. Our application doesn't really do anything at the moment, but just to make sure that it runs, let's add a quick, simple route, app.get. On the home page, we'll do an async request and response. And we're just going to say message, happy May the 4th. So let's start up our server and just make sure that our application runs so far. So I'm going to clear this and say node index. And we have this one in use. So make sure that we clear up the port and redo it. So node index should be running. And if we go to localhost 8080 / we get our message, happy May the 4th. So far, so good. Let's go back to VS Code. And the next thing we're going to want to do is actually connect to our MongoDB instance that's running on DigitalOcean. So to do that, what we're going to do is, first of all, set a variable called letDB, which is going to hold our instance of the database connection, so that once we are connected, we don't have to make a connection to MongoDB every single time we call a route. We're just going to store that variable globally, and we'll store it in this DB variable. And then from here, we're going to let our MongoDB client be new Mongo client. And in here, what we need to do is pass in our connection string, which we could copy and paste this hard-coded string, or we're actually going to use that environment variable. So we'll say process.env.mongodb URI. Let's make sure that those match up. Yep. And then the second thing we're going to do is pass in any additional options we want to our Mongo client. And that is just a JavaScript object. And the two we're going to pass in is use new URL parser, set that to true, and use unified topology. We'll set that to true as well. This is just going to make it so that when we connect to MongoDB, it's using the latest and greatest features of the Mongo driver. And then once we have our connection set up, we're going to actually go ahead and connect to the database. So we're going to say client.connect. And then once we are connected, we're going to get an instance of our client. And we're going to set our database variable, this variable on line 6, to our client.db, which database we want to connect. And that's going to be called Star Wars, because that is our database name here, Star Wars. And we should be good to go here. And now let's go ahead and see if we can load our data in our Node.js application from our DigitalOcean MongoDB cluster. And what we're going to do is just here, kind of very lazily without any sort of error handling, just run a db.collection characters. So we're going to go into our Star Wars database, into the characters collection, and just get all of the documents, set them to an array because we're going to get an array back, and just response this in JSON format. So I'm going to restart the database here with node index, go back into my browser window, hit refresh, and there we go. We have all of our data that we had in MongoDB Compass that we imported earlier in our collection. And just to make sure that that does work, that we are getting live data, let's go in here and change Luke's height from 1.72 to maybe 1.725. Hit update. And when we refresh, here we have 1.72. And now it's 1.725. Now, before I continue, let me take a quick look at the chat, see if there's any questions. Hey, Jimmy. Hey, Aziz Bey. Hello, hello. Welcome. Thank you for joining us. We are building a May the 4th Star Wars battling or voting application, if you will. And so far, we've built our simple server to simply display all of our characters in our collection. Now, the next thing we're going to want to do is actually start building out that UI. So let's go ahead and make a couple of additional changes to our Express app here. So the first thing we're going to do is we're going to need to set our view engine, app set view engine to EJS. And what this is going to allow us to do is create HTML files in this .ejs format, which is going to allow us to very easily add embedded data from our backend server into our HTML templates. So that's EJS. And then we're also going to create a folder here called views, which is going to store our particular endpoints. And in here, let's have one view be character.ejs. And we'll create another one for our battle or voting system. So our character embedded JavaScript file is going to look a little bit like this. So instead of typing it fully, I'm just going to copy and paste it and then walk you through the code. So we're going to bring in Tailwind CSS just to have a simple, nice UI. And if you go to the character endpoint in our application, we're going to display that character's name, as well as their ID, their image. And again, this is all data that is stored in our MongoDB collection. And then we're also going to display their number of battles won with a character.wins property. Now, at the moment, we don't have it in our data model here. Nobody has any wins because they haven't fought any battles or won any battles. So, that's okay. We'll get to that. But let's save this page here. And then for our battle as well, I'm just going to copy and paste and explain to you what the code looks like. So again, we're going to be bringing in Tailwind CSS to have a nice UI. We're also going to bring in this JavaScript confetti library just so that when we do have a winner, we can kind of have some fanfare for the winner. And then we are going to, actually, we could remove Sammy here. We're going to have two characters. So character 1, their name and their ID, as well as their image. Character 2 with their name, ID, and image. And then this on-click function called win. So whichever character you select is going to win the battle, if you will. And then we have just a little bit of JavaScript to handle our winner. So we're going to instantiate that JavaScript confetti library. And then we have our async win function, which is going to call our Node API and write some data to our MongoDB database, hitting this winner endpoint and just passing along the ID of the winner. Once we get our data back, if it's all good and successful, we're going to throw some confetti on the screen and then reload and start up a new battle. So that is the code there. Let me take a look in the comments, see if anybody has any questions so far, if all of this makes sense. Going once, going twice. Feel free to ask any questions, and I will continue coding along. So we have our view set up, our battle and character. Let's go implement these routes in our application. So I'm going to go back into index.js. And below here, below our app.get, we're going to create the remainder of our functions. So we have two of them that we need to create. The first one is going to be to simply display the character. And the way we're going to do this is we're just going to pass in an ID of the character, and we're going to use that data to filter our MongoDB collection to just get us the one character that we're asking for. So again, we'll make this an asynchronous function. And the way that this code is going to look is we're going to store our character data in this const character variable. And again, we're just going to call our MongoDB characters collection. So characters. Now, instead of running a find operation where we want to get an array of data back and multiple documents back, we just want to find one document. So we'll run a find one operation. And the first thing that we need to pass into our find one is our query filter. So just like we added filters here to display characters by their eye color, we can add filters in our find one operation. And we're going to say find one character, and we're going to go off of their underscore ID field, and we're going to get that from the request parameters.id. So whatever parameter you pass in here as the ID is what we're going to use to find our character. Now, one other thing we need to do is when you pass in this ID parameter, by default, it's going to be a string. And in our MongoDB database, our IDs are integer values. So we can cast this to a number. And that should work just fine. Closing. So too many parentheses, closing braces in the wrong place. So this is going to get us our character, and then all we're going to do is render that character. So now we're not passing JSON data back to our browser. We're actually going to render a view. In this case, our view is going to be character. So by default, it's going to go into this views folder and character EJS file. And then we're going to have to pass it our character so that it knows which data to load. So let's restart our server and see if this endpoint works now. So I'm going to go back into my browser, and let's go /1. And we should get Luke Skywalker with the ID of number 1, his picture, as well as battles 1, which he hasn't won any yet. If we do another character, say 2, we get C3PO. And if we do another one, say 25, we get Lando, and so on and so forth. So now our application is kind of starting to come to life. Let me take a look at the questions before we move forward. Jakub says, hello, I am your Turkish follower with love. Hey, Jakub, sending love back. And yes, this session will be recorded and will be on YouTube right after. As soon as we're done, it's going to be automatically posted on YouTube. So you'll be able to rewatch it. I'll also share the repo with all of this code at the end as well, so that if you want to follow along or build on top of this application, you absolutely can. So we have our character page If we try to hit that battle endpoint, though, we're going to get an error because we don't have our characters yet. Or we have the battle page created, but we haven't implemented the endpoint. So let's go back into our application and make those changes. So we're going to add a new route called app.get, and this one we'll call battle. And we'll make it an async function with a request and response. And the way that this battle endpoint is going to run is we're going to get all of our characters, essentially our roster of heroes, our roster of Star Wars characters, and we'll say const data equals, I'm just going to copy and paste the same query here. So in our data, once this promise has resolved, we're going to get our list of 87 characters, and we're going to response render our battle EJS file, and we're going to say, for example, data 0, 2 is going to be data 1. And I'm just kind of doing this really quickly just to make sure that this endpoint works. So let me restart our server. So essentially what happens is we go into our database, get all of we go into our MongoDB database, get all of the characters. And in this case, we're just going to get the characters at index 0 and index 1. So if we go back in here, refresh our page, we get Luke Skywalker and C-3PO kind of battling each other. So depending on which one you click on, they'll win the battle and we'll load up the next combatants. So let's, Luke Skywalker, he's great. Let's click on him and see what happens. Well, nothing happens because we get the server has responded with a status of 500 internal error because we hit this winner endpoint, but we haven't implemented the winner API route yet. So let's go ahead and do that next. So the way that this route is going to work is we'll just do it up here. We'll say app.get, and the endpoint is winner. And it's request response. What we're going to do here, rather than go and find data from our MongoDB collection or write a query filter, we're going to actually update our document in a specific collection. So to do this, let's try. We'll do a try catch. And in case we get an error, we're just going to respond with the error. But our try condition is going to look like this. So we're going to say const data to capture the response we get back from MongoDB, await database.collection characters. So all of this is pretty standard and the same as what we've been doing so far. But now, instead of running a find one or a find operation, we're going to run an update one operation. And the update one operation takes at least 2 parameters, which is the filter, so filtering out which document we want to update. And then the second is the actual update operation we want to perform. So what we're going to do here is find our character based on their ID. And again, we can do this by using by typecasting. And in this case, we're going to capture the query parameter. So rather than passing in a URL parameter, we're going to pass in a query parameter called request query ID. And you can see that in our battle here, when we call the fetch operation, we're hitting the winner endpoint, and then we're passing in a query parameter of ID with the ID of our character. So we have underscore ID. We're going to cast it to a number, the query ID that we get. So that's going to find which document we want to update. And the second parameter we're going to pass in is the operation is the update operation that we want to perform. And in this case, what we're going to do is we're going to call the $inc or increment operator, which is going to increment a specific field. And in our case here, we're going to increment the win field by 1. When you save this, it's going to clean up some of the code just to make it easier to read. So again, we're going into our database in the characters collection. We're finding our character using the underscore ID, passing in the query parameter ID, casting that to a number, and then incrementing the wins counter by 1. And if there is no wins property that exists on the document, it's going to be automatically created, and we'll start the counter at 1. And then all we're going to do is response JSON our data. And the data we're going to get back here is from MongoDB, which is going to say how many documents were updated, how many documents were found, and if the operation succeeded or not. So let me save this, restart the server, and let's try to run our operation again. So I'll go back in here, I'll refresh the page. And again, we have Luke Skywalker versus C3PO. And let me open up the terminal as well, or our console window here. And let's have Luke Skywalker win this battle. So I'm going to click on him, and we get a bunch of confetti. We had that return statement to show that we were able to successfully update the operation. And actually, to show you what that response looks like, we can actually just hit the winner endpoint, pass in an ID of 2 in this case, so that C3PO has a win as well. And when we execute it, what we get back from MongoDB is how many documents matched that particular ID of 2. 1 document matched. How many documents did we modify? In this case, we incremented C3PO's wins by 1. So 1 document was modified, and then we also get this acknowledged true, saying that this operation was successfully written to our MongoDB database cluster that is running on DigitalOcean. And now if we go into, for example, C3PO, battles 1-1, and if we go into Luke Skywalker, he's also won 1 battle, and if we go into number 3, R2D2, he hasn't fought any battles, so he is at 0. But this app isn't really all that great because we're only having 2 characters fight with each other. So let's actually make this a little more interesting, and I'll add a quick function here that's going to go through that characters array and get us, kind of randomly select 2 characters to fight each other. So that's what this get character function is going to do. And then we'll do a little bit of refactoring here in our battle to actually get us random values. So we'll say const1 equals get character from 1 to data.length. And const2 is going to get character 1 data.length. And then we're just going to replace the 0 and 1 with 1 and 2. Restart our server and go back to our battle. Here we go. So now we're having Obi-Wan Kenobi fight Anakin Skywalker. Who do you think would win? Anakin. So let's change history. And we get our confetti, meaning that it was successful. Here, we can have as many battles as we want, and each time we click on the button, data gets automatically updated and saved in our MongoDB database. Chris says R2D2 deserves all the wins. I totally agree. This is a hard one. Mace Windu versus Darth Vader. Mace, got to give it to him. And we can do this all day as much as we want. And actually, if you want to play this, try this app on your own. We actually do have it deployed live. So let me get you that URL. I'm going to post it in the chat. It is this Seashell app here. And /battle. And I actually added a little Sammy the Shark Yoda. I didn't do that in the app we're building live, but let me share the live app in the chat if you'd like to trial it, test it yourself. But going back to our local version, Mace is always going to win. And Yeah, so that is the application we built, and we are right on time at the top of the hour. But I do want to take a couple of minutes and see if there's any questions in the comments, if there's anything else you'd like to see me show before we wrap up for today. Otherwise, thank you so much for joining me. Happy May the 4th. And also let us know what else you'd like to see in these tech talks, whether it's MongoDB related or a different database engine, different technology. We host these for you, for the community, and we want to empower you, teach you some cool new stuff. And I hope you enjoyed the demo app today. I can also share the GitHub repo as well. So let me do that. Copy link. So if you want to download the code and test it yourself, feel free. It is right here. Otherwise, I'll hang out for another minute or two and let everybody get back to their day. Thank you for joining me, and have a great rest of your day. Happy May the 4th. I hope you go and enjoy, hopefully watching some of the new or older Star Wars movies, whichever you prefer. Thank you all. Bye-bye.